Hello friends, welcome to our class. Today we're going to talk about a very important question, a question that could define our future, the future of this planet. Imagine, what if you could pull treasure from the depths of the ocean? Imagine, you could make it rain whenever and wherever you want. Sounds like something out of a sci-fi movie, right? But this isn't just a movie anymore. It's becoming real. Should we mess with nature on such a big scale? Will it be a blessing, or a curse we can't undo? Think about it. Today we'll look at the facts, understand the arguments, and try to make an informed decision. Come along with me on this journey. Let's get started. So first, what exactly is deep-sea mining? Let's understand it in simple terms. Imagine the ocean floor as a huge treasure field. Thousands of meters below the water, in the dark, there are things lying around. Polymetallic nodules, copper, nickel, cobalt, manganese. These are the same metals used in your smartphone batteries, electric cars, and all modern gadgets. Now the question is, how are they taken out? Imagine a huge vacuum cleaner, but it's as big as a small house. This robot moves along the seabed and sucks up the nodules along with the dirt and sand on top. Then they are sent up to the ship through a pipe. On the ship, these nodules are cleaned and stored. So the question is, why are we taking such a risk? The answer is one word: demand. We live in a world that runs on technology. On land, the reserves of these metals are very limited, and extracting them harms the environment. Land mining requires cutting down forests and displacing people from their homes. Supporters say there's a huge reserve under the sea that could meet needs for centuries. If we want green energy, we need metals like copper, nickel, and cobalt. All of this is present on the ocean floor. In a way, it's an answer to the resource crisis. Today, the supply of these metals is controlled by only a few countries. Deep-sea mining could offer an opportunity to every country. This would reduce dependence and could offer a strategic advantage. But every race has a cost. What's the cost of this race? Next, we'll look at its environmental cost. Now let's look at the other side of the coin. Not everything that glitters is gold. The environmental concerns associated with deep-sea mining are very serious. The biggest threat is the loss of biodiversity. These organisms grow slowly. It takes thousands of years for them to mature. If their habitat is destroyed, it could take millions of years to recover. Imagine, if a bulldozer ran over your house, that's what would happen to these creatures. The second big threat, sediment plumes. When the mining machine digs the bottom, dirt, sand, and particles fly up. These plumes can spread for miles in the water and block filter feeders. Food sources will be covered, increasing the risk of ecosystem collapse. The third concern, noise pollution. The 24/7 noise from heavy machinery will be disruptive to these creatures. Light pollution will disrupt their communication and behavior. Everything could be disrupted. This experiment could be costly for us, and we don't know what the results will be. Now let's go up to the sky. Our next topic is geoengineering. This is an ambitious and controversial field. Geoengineering mainly has two types: solar radiation management and carbon dioxide removal. The idea of SRM, reflecting heat coming from the sun. This includes ideas like spraying aerosols or space mirrors. The goal of CDR is to absorb and store CO2 from the atmosphere, direct air capture, ocean fertilization, or large-scale reforestation. One part of weather modification is radar-induced rain or cloud seeding. Radar as a guide, seeding as an inspiration, and fog farming, collecting fog with nets to get water. Both have different scales of thought and risks. But is it safe to code nature's software? This is a very complex ethical and technical question. So let's understand cloud seeding. Cloud seeding, silver iodide or dry ice, is released from planes, rockets, or ground generators. These particles act like seeds. Droplets gather around them and form rain. Fog farming. Large mesh nets are set up in coastal and hilly areas. Fog passes through the nets and water condenses and collects. Slowly, the droplets collect in pipes. Clean drinking water can be obtained without rain. Dubai uses cloud seeding. In Chile and Peru, fog farming provides water to villages. These technologies offer hope, but there can also be side effects. Next, we'll look at the pros and cons of these technologies. Do we want to live with unintended consequences? The biggest benefit? Water. Artificial rain or fog harvesting can be life-saving. Millions of people could get clean drinking water. It would help farming. Rain can reduce pollution. It can help prevent forest fires. It can be useful for airports, events, and emergency responses. There are many immediate benefits. Food security and livelihoods can improve. The biggest drawback? Unintended consequences. If we make changes in one place, it can affect the whole system. While we solve a drought in one place, another place might experience drought. Will someone have the power to decide rain? There's a risk of misuse and the threat of weather wars. This could create new inequalities between the rich and the poor. Scientists say we should adopt the precautionary principle, research first, then deployment. We need to think beyond short-term benefits. With every new technology, two kinds of voices emerge, one of hope and one of concern. Humans have always turned to technology to solve problems.
A mining CEO. If we want a green future, metals have to come from somewhere.
A farmer. If technology can water my fields, what could be better?
Environmentalists and many scientists have serious doubts.
Marine biologist. We don't know even 1% about the part of the ocean we're going to dig up.
They say, we need transparent public debate and regulations. Future generations will never forgive this mistake. We need to think about the long-term consequences. Perhaps the answer is, we all decide together. So friends, today we understood both sides of two powerful technologies. On one side, deep-sea mining, on the other, geoengineering, both with hopes and dangers. These aren't black and white questions, it's a gray area. We need to weigh short-term benefits against long-term risks. We need more research, transparent debate, and international regulations. You've heard both sides. Now I ask you, should we mess with nature like this? Please share your opinion in the comments below. Your voice matters a lot. Let's continue this conversation. Jai Hind, thanks for watching. Subscribe for more, and let me know in the comments.